Nisha, and they are my teammates Sai Kiran and Niket. The title of our project is Smart Ordering System for Restaurants for TIIC IDC Contest 2015 with CMT ID 1017. Our research in restaurant management has let us understand the peeves and problems faced by restaurant owners and managers on daily basis. Few countries are completely dependent on foreign labor for the service industry. But hiring restrictions lead to an overall restriction on the staff, leading to overemployed, unhappy employees and slow turnaround time at the dining table and many more inefficiencies. Now imagine these cures are organized by a systematic engine by channeling information throughout the kitchen wirelessly and keeping track of each and every item ordered, cooked and delivered. At the end of the meal, it will have an exact bill at the table with no human errors, and all these tasks will be completed within a short period of time. The pragmatic automation is very much in need for the present day restaurant systems. The project deals with automation of restaurant, ensuring customer satisfaction and with commercial elements. As the customer presence is detected with the help of the IR sensor, the LED and the voice playback module are activated welcoming the customer. The LED architect and the power supply is designed through the TI's web engine. The app consists of a menu. We can select the dish we would like to order and the image along with its cost and nutritional values will be displayed. Once the customer sends his request, it immediately gets transferred to the cooking section and the order will be confirmed by the cooking department through sending an acknowledgement of the total bill which can be payable through the smart card. If an app is in inactivity mode for 10 seconds, then the commercials will be displayed.
Being a practical automation project, the customer satisfaction needs to be given utmost importance. As discussed earlier, the project mainly aims to create a low-power, cost-efficient, hardware-efficient, and user-friendly restaurant environment. Coming to the hardware section, we just completely divided two parts: a transmitter section and a receiver section. We even proposed an algorithm which can avoid interference in 2.4 GHz ISM band through adaptive channel hopping technique. Because we are using that ISM band to transmit the data between transmitter section and receiver section, which are embedded at a table and the cooking department. Each and every table in the restaurant, it will act as a transmitter section. Now let us see the hardware components of transmitter section. The MSP430 launch pad, the sensor, the voice playback module, LCD display, smart card reader, serial switching circuit, CC2500 RF transceiver, and the power supply section is capable of driving 5 volts and 3.3 volts using ICs UA7805 and LM3489. This power supply section is designed and implemented using TI WebEng application. The serial switching circuit consists of ICs MAX232, a TTL to serial converter, and a multiplexer SN74LS244 from Texas Instruments. The purpose of using this circuit is to avoid the complexity of using multiple UART devices like smart card reader and CC2500. As these devices communicate to serial port, these outputs are multiplexed using this multiplexer IC, and the outputs from this multiplexer IC, that is serial switching circuits, are connected to this launch pad. Now let's go in detail regarding the hardware of this transmitter section. Even this LED architect is designed using the reference design from WebEng application. As soon as the customer presence is detected through an IR sensor, the LED lights glow, giving him the candlelight experience without missing the essence of restaurant. Simultaneously with the LEDs, the LCDs as well as this voice playback module gets activated welcoming the customer.
Welcome to TI Modern Restaurant.
Let's see the deferment of bill by the customer. After the customer insert the card into the smart card reader, the compiler will read the amount of data present in the smart card and then detects the amount which is transferred from the CC2500, which is stored in a temporary variable, and detects the amount from this balance amount, and the balance will be displayed in the LCD. and then the card can be removed. Acknowledgement system can be displayed, will be displayed in the LCD. Where the transparency in billing system is improved to a maximum level, ensuring the customer satisfaction. Coming to the receiver section, we have the following components: MSP430 F series experimental board, RF transceiver CC2500, and Bluetooth module HC05. The purpose of using serial switching circuit again in receiver part is to multiplex the outputs coming from CC2500 as well as HC05 Bluetooth module, and then giving the inputs of this serial switching circuit to this MSP430 F series board. The total amount payable and the total items ordered can be displayed in application design at the table. This happens by transmitting the Bluetooth data from the experimental board to the HC05, then to the Bluetooth application design in the Android app. Now let's see the working of this receiver section. First of all, we need to pair our Android application to the receiver section. After connection is accepted from the parental node to the child node, actually this part is done by using adaptive channel hopping through each and every individual table. Now the customer can choose any of his desired item through which it can be displayed in the GLCD, which is inbuilt in F series of MSP430. Once the customer is satisfied with his order, he can generate his bill by confirming the order. The customer once presses the confirm button, the same will be transmitted to the transmitter section, and then the total amount of bill can be payable through smart card.
Here, the power supply section is designed through the TIIC webbench, which gives high efficiency for driving multiple loads by LM3489, which gives 3.3 volts as output. Here, this is a schematic diagram where the input voltage is varied from 4.5 volts to 15 volts, which drives the IC LM3489, results the output as 3.3 volts. With this difference, we have designed our power supply section. Here there is a efficiency versus output current graph, where these three plots represent the efficiency of the power supply circuit when the input voltages are at 4.5, 8.25 and 12 volts. When the input voltage is at 4.5 volts, the efficiency of the power supply circuit is 93%. Through this webbench analysis, we applied input 5 volts to get 3.3 volts output for driving multiple loads with 90% efficiency. Using this reference design from webbench, we have designed the LED architect to drive the 5x5 LEDs.
Now let's see the pragmatic approach of our project in the real-time restaurant environment.
Restaurants need to be updated with trending technologies for the ease of customers. Restaurant automation may take drastic changes and may change the way we dine in future.